Hello class. Today we will start with a new chapter. The name of the chapter is Ideas on Algorithmic Efficiency. Okay. You have to have some ideas on algorithmic efficiency. Algorithmic efficiency. Okay. It is a very theory-based kind of a chapter. Fine. You don't have to do much of a programming here. Rather, you have to judge whether the a program which is written is a good program. Or not so good as a program. Algorithm-wise, it's good or not so good. Now, what is an algorithm? Algorithm means basically the logic that you follow to solve a particular problem. If you write a program following a particular method, like you input, then you find the half of the number that you have input, and then you use a loop. So this step-by-step thinking, the techniques that you will follow, if you just write it down in normal words, normal sentences, just like the way we speak, like I am speaking, input a number, okay, and maybe find the half of the number, then use the half of the number to set a for loop. If these words, if we write in steps, my step number was input a number, step number 2 to find half of the number, step 3 set a for loop from within the range of 1 to whatever, then within the loop do this work. If step by step, if you write the process which you are going to follow while actually writing the code using Python or using any other language, that will be called an algorithm. Clear? So algorithm is basically a kind of pseudo code. We call it pseudo code. Pseudo code means it is not actually programming language or programming code. It is just a rough way of noting it down how we should go about it. An algorithm should be such in nature, looking at which you should be able to write programs, doesn't matter whichever language you know. Okay? So basically we have to judge the efficiency of an algorithm. If we convert that algorithm into a program, okay, doesn't matter which programming language you are using, will that be a correct way of doing it? Not exactly the correct way of doing it. Correct is not the right word here. Will it be smart enough to do it? Okay, let's see what all the things we have to do here. First of all, when we talk about the efficiency of an algorithm, there are two factors which play a very important role. You just see first here, okay, I will write all the things in details as usual in your notes. So first one is called internal factor. Okay. First one is called internal factor and the second one is called external factor. Fine. So what are the internal factors? Internal factors on which the efficiency of an algorithm will depend is, first of all, is the time required to run the algorithm. How much time it will take? If I convert that algorithm into program, how much time it will take to execute the program? And the second item, which plays an important role, is the space required. Okay? Time required and the space required. Fine? Space required means how much space it will cover. If you remember, while writing the programs, many times I mentioned that when you write a program, your target should be to take as less number of variable as you can. Always that may not be possible to implement that when you write programs because you are the beginners. Okay, but in the very high level of programming, programmers always try to take less number of variables as much as they can. Why? Because every variable that you write, the whole program that you write, that occupies the space of the RAM. Right? When you run a program, the program also runs in the RAM. So basically, the less amount of RAM you will utilize in terms of variables or in terms of writing programs, in terms of number of lines, what will happen? That program will be executing much faster. That program will be executing more efficiently. So our target should be always to occupy as much less space as we can. That's why space also plays an important role in determining whether an algorithm will be smart enough, efficient enough, or not so efficient enough. And there are some external factors also. For example, what kind of input you have. Okay, input size. Input size means, supposing a number which I want to input to run a program is 48. Now in this case, the way the program will run, if the number input is 48,000, obviously the program will not run the same way, because 48 is a very small number. Okay, but if I take 48,000 as input, then the scenario might change. Why scenario will change and how the scenario will change, that let us get deep into this topic, then we will understand. Okay, another factor which might play an important role is the speed of computer. Okay, speed of computer means whichever computer you are using to run the program. When a particular algorithm is converted into a program, whichever computer you are using, its speed also matters. If it is a slow computer, then I might not get the result very, very fast, or it might be delayed if the computer is a slow one in terms of processing speed. And number 3, what can play an important role is the quality of compiler. Quality of compiler means some of the compilers are very smart. They can do certain work using very small number of lines. Like Python is a very, very smart kind of a compiler or interpreter, that way you can say. But earlier days when GW Basic was used, GW Basic will not be that great, because to do a small thing, okay, you may have to do 2-3 lines, which can be very easily done by using a simple function. Okay, like for example, you have done in list. In list, you have seen list dot reverse. The entire content of the list got reversed. All the elements, the positioning of all the elements got reversed. But this kind of functions are not there in GW Basic. So you have to actually write programming code to do it. Fine. So what kind of compiler or interpreter you are using? Not only compiler, interpreter also matters here. Okay. What kind of compiler, what kind of interpreter you are using, that also matters. So these are the factors basically usually matters that whether an algorithm will be efficient or not so efficient. Now out of all this, mainly we will study this one, that is time, how much time it should take to execute. That we will study very, very clear, properly. And also another thing we will study, like input size. Okay. In fact, in this chapter we will see that if for an input size, how the time required by an algorithm will vary, or how it matters. That is what basically we are going to study in this chapter. Now, when we talk about algorithmic efficiency, the question is, how do we measure it? Okay, there has to be a measurement somehow. So to measure, a term is used called computational complexity. Computational complexity. This is the term which is used. What is computational complexity? By computational complexity, we try to measure whether an algorithm will be efficient or not so efficient. Basically, computational complexity is nothing but it's a kind of a study on some features or certain factors, study of certain factors on which basically the efficiency of a program will depend. Okay. Computational complexity is nothing but study of certain factors on which algorithmic efficiency will depend. What are the main things here? I told you this thing. Mainly we will study here all the internal factors that we saw. That is, one is called time complexity. Okay, one is called time complexity, another is called space complexity. Fine. But space complexity is not that what we are going to discuss here, because it is seen that space complexity doesn't make much of a difference. It makes a difference. It makes a difference, but its impact is not as much as time complexity. So basically, time complexity will play the most important role in determining whether an algorithm is an efficient one or not so efficient one. Fine. Now another term we have to understand here. Okay, what is that term? That term is called growth rate of an algorithm. Growth rate of an algorithm. What is it? Growth rate of an algorithm says that how basically the algorithmic efficiency will vary, how algorithms performance will vary as the input size increases. Fine. Say for any algorithm, n is the input, n is the number input that is required for any program to complete properly. Now if I increase the n size, okay, how does it basically impact on, or how it influences the algorithm? That is called the growth rate of an algorithm. That means basically in a very simple word, on input, if we keep on increasing the input, how basically the efficiency of an algorithm or the performance of an algorithm will vary. That is called growth rate of an algorithm. Fine. So this growth rate basically is represented by a term called big O notation. Big O notation. Okay. What is big O notation? I am giving you an example here. What we do, we write a capital O, and as a function of capital O, we write a factor like n. This means On. Big O in big O notation, On means, if I say an algorithm's efficiency is On or an algorithm's growth rate is On, which means that the performance of an algorithm will depend on it. How it will depend on it? Basically it means that the algorithm will take n steps to complete. Okay, it will take n steps to complete the job, or it will take n times, we can say On times to complete. Now when we are saying On time and On steps, what do we mean to say? Okay, remember this, if we say an algorithm's basically growth rate is On time, okay, it takes On time. Here time is not any kind of unit of time, okay, like we are not saying that it is in terms of microsecond or millisecond or picosecond, okay, not that, not, there is no unit of time involved. Here the word of time is not literally what we mean to say by time. Here the word time is a kind of comparison. For example, if I write another, for example, big O notation, say 2n, okay, that means for an input size n, if we give an input n to an algorithm, this algorithm will take 2n time. Okay, so basically this time and this time are not any unit of time. They actually do not mean to say time. They mean a comparison. That in comparison to this, it will take more time or less time. That's what the word time is used for. Here time is not millisecond, not microsecond, not even picosecond. Not those. Fine. And if we say that for an algorithm, the big O notation, by big O notation, the growth rate of an algorithm is On. So basically that algorithm takes n steps to complete a job, whereas this one takes 2n number of steps to complete a job. Now what is 2n number of steps here? 2n number of steps or n number of steps doesn't mean that there will be n number of lines or 2n number of lines. Lines are not the steps. What are the steps? Steps here is also doesn't mean what we actually mean to say by the word step literally. What it means? For example, if we take a for loop for I in range, let me write it here. If we write for I in range 1 to n and say here, or say I have written n plus 1. Okay. Here in this loop, say I have done one take statement, something else, there are 3 statements written. Statement 1, statement 2, statement 3. Fine. So here basically step means this entire block. That means how many iterations will be there? How many times this for loop will work? This for loop will work n number of times. So n number of times these 3 jobs have to be done. So we can say that this particular loop is going to continue for n number of steps. Here steps, this all three statement is a step. So it is not the number of lines. Okay. It's a general way we say that it will take n number of steps. Okay. That is how it is represented. So when we say by BO notation that the growth rate of an algorithm is ON, it means that for an input size n, that particular algorithm will take n steps to complete a job. Similarly, in this case, this algorithm, whichever algorithm's growth rate is O2n, for an input size n, this particular algorithm will take 2n number of steps to complete a job. Okay. Again, I am repeating, these steps doesn't mean number of lines. Okay. Or we can say that growth rate of an algorithm is ON times. Here the time is not any unit of actual time. Here the word time is basically, if we compare it with another algorithm's time, whether the time is a less amount of time or more amount of time. In that connection, the word time is used. Okay.